everybody. Welcome to join us to discuss this AB level for computer science question 7 to question 12. First, let's take a look around at question 7. It mentioned that an array with no duplicate values is to be sorted into increasing order using heap sort, and step 1 is to insert the elements of the array sequentially into a maxima heap. So recall that a max heap with no duplicates is a complete binary tree in which the value in each node is larger than the values in its children's nodes. So if the given array is 6719208, what will be the contents of the max heap be after all the elements are inserted? So you see, we know that at the beginning, the first elements of the array will be inserted to the root. Then the second element will be inserted into its left subtree, the root of its left subtree. Then the third elements of the array will be inserted as the root of its right subtree, and so on. So as long as there are 2 to the n minus 1, that many nodes, then in this completed binary tree, we can build a max heap just by gradually inserting starting from those nodes with a higher level. But remember that there should be some checking procedures. For example, if it's the max heap, there do exist some property that comparing to the root of the left subtree and the root of the right subtree, and also the root of this tree, the root of this tree should always, the values of the root node of this tree should always greater than or equals to the roots of both of its subtrees. So if it's a max heap, we can check that. Let's take a route for this 5 different maxima heap choices. We know that choice A, obviously, if we compare 6 with its left subtree, the root of its left subtree 9, and also the root of its right subtree 8, 6 is less than both of them. So this is not a maxima heap. So we don't have to consider choice A. For choice B, if we see the left subtree, 6 is not greater than 7. So we don't have to consider choice B. How about the choice C, G, and E? If we check up almost content of choice C, choice D, and also choice E, all of them fits into the maxima heap. So right now we cannot just use the basic properties of the maxima heap. Instead of that, we have to consider the sequence of the insertion. Okay. Now, if it inserted as the sequence 6719208, then at the beginning we will assume that 6 will be at the top root, and its left should be 7, and its right should be 1. After we inserted for the first 3 elements. But when we inserted 6 and when we inserted 7, since 7 is greater than 6, so there will be a switch. That means there will be repolling up to exchange the elements of 7 and 6. So after we inserted 7, the tree should be a skew tree with root 7 and its left node, the only leaf of its left subtree, 6. Then we inserted 1. Then that becomes 7, 6, 1 after we inserted 3 elements of this given array. Now let's continue inserted 9, 2, and 0, 0, and 8. Okay, if we inserted 9, then that 9 element should be on the left-hand side of the original element 6. Since 9 is greater than 6, so we have to repol up the element 9. We switch 9 with 6. Then it becomes 7, 9, 1, 6. Now the root is 7, which is less than 9. So this element 9 will be ripple up again. So it becomes 9, 7, 1, 6. Okay. Now, if you see until now, we know that the element 7 should be on the left subtree. And if you check the choice of C and the choice of E, the 7 is on the right subtree. So we don't have to consider the insertions of all the elements. Then we know that the correct choice should be D, because 7 is on its left subtree. Okay. Next is question 8. It's about a very basic concept of the inaccuracy of the calculation, especially if we combine the divisions and multiplication and also the Boolean expression. Okay, the question is as follows. Which is true of the following Boolean expression given that x is a variable of type double? Okay, if x is a type double, then we want to compare whether the following values are equal. Okay, on the left-hand side of this equation, the comparison, it should be 3.0. It's just absolute value of variable 3. And on the right-hand side, first we let 3 divided by x first. Then we multiply x back again. If it's on the algebraic manipulation, we can easily just try to guarantee that once we cancel out x, it should be equal. But however, since this is in a computer calculation, and also there is some parenthesis for regulate the sequence of the calculation, which one goes first, which one goes the rest. And besides, if some operation goes first, then instead of the memory of the execution of the program, there should be some space that will be restore the temporary results. But just based on how complicated this x is about. If x is a variable of type double, but it has a lot of sequence of digits, if we use the 3 to divide it by x, then the results that has been restored might not be able to list all the possible accuracy of the results. So once we multiply back the x, it might be a little bit larger than original 3, or maybe a little bit lower. It just depends on after you store the results of 3, that 0 divided by x, whether the execution, the Java runtime environment, will store it rounded up or rounded down. That means if we read these 5 choices carefully, A, it will always evaluate to false. That's probably not true. For example, if we set up x equals to 1, then 3 divided by 1 will be 3, then 3 times 1 is still 3. So there will be some cases when the evaluation could be true. So we should not choose A. B, it may evaluate to false for some values of x. For example, if x is equals to pi, then probably there will be some problem. Or x, like what we said before, if x has too many digits that beyond the storage after we do the division and also the multiplication. So B is our choice. Let's see how come. Is there any errors for the rest of the 3 choices? Choice C mentions that it will evaluate to false only when x is 0. But I mean, as we discussed before, if x has some other cases, it might still evaluate to false. And also D, it will evaluate to false only when x is very large or very close to 0. Not really. I mean, if the number of digits is very long, then no matter x is large or small, it does not even try to require that x will be close to 0. Now choice E, it will always evaluate to true. Apparently, this is impossible. So the choice is B. The next slide is about question 9. This question 9 is about to test our concept about Iterator. We know that Iterator has been provided by the new versions of a Java language so that we don't have to check the content of, for example, a bunch of data by indexes. Because sometimes if we want to use the indexes to track, to insert or delete elements of, for example, like array list, for example, like linked list, we might have to be very careful about the index. But if we use iterators, we only have to make sure that once we try to call, the function has next, and also once we call the function, the method next, it will return the correct content. So iterator has the advantage that we don't have to take care of the index. Okay, now the preconditions of this is given a word list, which is an array list of string. And the post conditions of is that is all occurrences of the word removed from word list. Note that this word is a specified string. Since word list might have a lot of different streams, which might also have some repeated versions of the same stream, which has the same values of the stream word. So it needs to be removed, all of them. Now let's see. This method is called public void remove word with two input parameters. The first parameter is called array list of type string called word list, and the second is called word of type string. Now there are three possible implementations. Which implementation code will produce the required post condition? Let's check. We have 1, 2, 3. The first choice is it completely used the method and also the functionality provided by the iterator. First, it's trying to declare an iterator of type string called itr, which is the word list.iterator. So we just trying to call the iterator method and return all those tokens that has been interpreted by the iterator method. Now there's a simple while loop. We ask this itr to check whether it has next element or not. So if there's still some element of the string, this array list of a string, or the iterators of strings, then we check that. If the itr.next that returns of a variable of type string, so we can use a string that equals to compare with another string. So string 1 that equals string 2. If string 1 and string 2 they have the same content, it will return true. Otherwise, they will return false. So if itr.next that equals word, which means that if the current token that has been split and examined by the iterator is equivalent to the content of the word that we want to examine, then we call the itr.remove to remove it from that. So apparently, the first choice is very basic and also fundamental usage of the iterator. Let's check the second implementation and the third implementation. The second implementation trying to mix up with the index and also the iterator. We know that the first line is almost the same like the first choice, but in the second line, it used one index I starting with 0, and also for checking while the while loop will check all the content instead of the iterator. Once the iterator still has additional token that it will return, then we do the following checking. Again, we use itr.next that equals word to check whether the iterator, the tokens that has been examined by iterator, is equals to the content of the word or not. If there do exist the appearance of such that, then it calls the following: word list that remove I, then it increase I++. Okay, this will be one problem. For example, if at the beginning of the stream word list, the first element of the word list happened to be the occurrence of word, then here the index I is equals to 0. Now if word list doesn't remove 0, then which means that the first element has been removed. The next while loop, if we check it also has the same word, then that means the second element of the original word list also contains word. But since the index I plus plus, so right now it will remove the first element instead of the 0th element. So that means if we mix up the index I and using the I plus plus with the remove and the iterator, we will not be able to locate the correct one, because if you remove I, then your I plus plus should not execute it. If the word list is not equals to the iterator of the next, then the index should increase. So that's why there are some errors of the second implementation. Let's see the third implementation, trying to use, instead of getting advantage of the functions provided by the iterator method, it trying to use index I starting from 0 to word list the size and increase the index of I plus plus. Seems like a very safer implementation. Let's see. If it's inside of this for loop, also it's trying to use word list dot get I that equals word. So if we get the index of the word list of index I, which happens to be the content of the word, then we call the following word list that remove I. The same problem happens when we examine the second implementation. Now, the I plus plus should be reversed, because when we check the next element, since the current element of index I has been removed, and since it is an array list, the next element of the element that has been removed will be shifted forward to fill in the current element that has just been removed. So as long as the content has been removed, then we have to reverse the increase of the index I, just so as not to mix the next element, the check of the next element. So that happens for the errors of the second and also the third implementation. So what does that mean? Among all these 5 choices, we can only choose A. That is, the first implementation is the only correct implementation of the iterator for checking whether this word exists and also be cleared out from the array list word list. Okay. Question 10 and question 11 has 2 conditions. The precondition is about the current ref refers to a node in a linear linked list of character streams, and the current is not null. And the post condition is about the node following the node that the current refers to contains a blank. Okay, so what does that mean? That means if we specify the current position, the insert blank method will do the following things. You are trying to insert a blank. If the current element has some next element, then among this current element and also the next element, there will be a new element, which is the blank. Okay, so let's check the example 1 and example 2. It's very clear. In example 1, the current will point to an item which has value A, and the next of A will be another item which contain another value of A. So once we call the insert blank, there will be an additional element which does not contain anything but just the blank items between the original A and E. In example 2, the current item actually is the last item of the linked list. So once we call the insert blank, actually, we will insert an empty blank element at the end of the linked list. But I mean, current still does not change. So let's see the next slide. So which of the following could be used as the body of insert blank such that its a post condition is satisfied, which means that it will insert the correct element of once we inserted the linked list. Okay, there are 3 choices. The first choice is as follows. Let the current node called setNext, and the setNext is a initialization of a node, a list node, of constructor parameters of empty and also current.getNext. What does that mean? That means we're trying to set up the next node of our current node with a new node, and that new node is an instance of class list node, and also this new list node has a symbol, blank, empty symbol, and the current, okay, and this empty symbol, its next node will be assigned as the original next node of current. That's why in the constructor, the second parameter will be the current to get next. It's like the example 1 that we just saw before. So the first implementation is the correct one, but I think they just are trying to save the space, so they initialize the node without just giving a declaration of it. But it doesn't matter, which at least we know that the first implementation works. Let's see the second implementation. Okay, right now they have a declaration. They declare list node p equals to new list node, and the second variable will be current that get next. Now it let current equals to p. Is there any problem? Yes, because right now it's not a linked list. The current has been removed, but according to these 2 previous examples, after we executed the insert blank method, the current should not be changed. So we don't have to consider the second implementation. That means we don't have to consider choice B and also choice D. Right now, how about the third choices? If the third implementation is correct, then we will choose E. If the third choice is incorrect, then we can only choose A. Okay, let's see. The 4 lines of the third implementation is as follows. Again, it's trying to declare a list node with name P with the new list node initialized with null and null. Okay, at the beginning, it even does not try to insert it and assign the symbols to this new list node. And also, it even does not try to set up the proper content of the next node of this new initialized list node. But on the other hand, in the second line, it let p.setNext equals with the parameter current.getNext. That means it's trying to let P, this new initialized list node to be inserted and pointed out to the correct next node of the current that get next. And in the third line, it let P set the value to be empty. So apparently, after the 3 lines, P becomes the correct blank list node. Okay, what's missing? What's the only missing step? Actually, it has been fulfilled on the 4th line, because right now, once P has been inserted, we have to make sure that P will be the next one to the current node. So in the 4th line, we assign current that set next to P. So if we check example 1 and also example 2, we know that the third implementation is also correct. Okay, now we know that we have to pick choice E, 1 and 3 only. Question 11 is about a method padlist. And also, please remember, we just implemented the insert blank, and this padlist method will use part of the function that has been provided by insert blank. So what does this method padlist describe? Actually, is as follows: whose code is given below, and also this padlist method is trying to insert a blank between each pair of existing nodes in its parameters list, a linked list of character streams. And for example, if the list is initially as follows, okay, we know that the picture, right? The list has been pointed out to a linked list with content A, B, followed by A, and also C, followed by B. After we run the padlist and also with parameter list, then it should result as follows. That is, the list reference still point to the node A in the original linked list. But then after the A node, there is empty node. Then after the empty node, there is the original B node, which originally followed by A, and so on. After the B node, there's another empty node, and also after this empty node, there's another C node. So if there are fewer than 2 nodes in the list, then the list should remain unchanged. So the following paragraph trying to describe and mention about the precondition and also the post-condition of this method padlist more carefully. The precondition of the padlist is as follows. List refers to a linear linked list of n character streams, where n should be greater than or equals to 0. And the list represents the sequence S1, S2, S3, S4, and so on until Sn, which means that originally it has n elements, n character streams. Then after we executed the padlist, what will happen? Actually, it will become 2 and minus 1 elements. So the post condition is as follows. List refers to the linear linked list representing S1, empty symbol S2, empty symbol S3, empty symbol, and so on, empty symbol until Sn. So the list remains unchanged if n is greater than or equals to 0 but less than 2. That means if n has 0 element, then we don't have to pad anything. If n only has 1 element, since it does not have its next element, so we don't have to patch anything. Okay, let's see. Question 11. If there are fewer than 2 nodes in the list, then the list should remain unchanged. Right. Okay, let's check. It gives the following implementation. And if you read this lines of code carefully, we know the public static void padlist of the input parameter list and node list. I think it looks very correct. It's just a very normal declarations of the method for the first line. And if a list is not null, what will be? Let list node temp equals to list, and also we use the while loop to check that. They use the while loop. Okay, the while loop check what? It checks that whether the temp.getNext is equals to empty element or not. So if it's not empty, then it tries to insert the blank of temp. Then let temp equals to temp.getNext. Okay, it's just that simple. But if you think twice, what will happen? Okay, suppose temp, the first element, it has following another element, so we inserted blank of temp. So what will happen for the insert blank? Actually, if you remember what insert blank works, if you insert blank at the temp position, the current reference to the current position will not change. That means the next element of the temp will be the blank element. But instead of this while loop, it let temp equals to the results of temp.getNext. That means once we inserted the blank element, it will to check this blank element. Instead of just jump toward the original element after the previous element that the blank element has been inserted. So what will happen? If there are more than two elements, actually, it will continue to insert the blank element after the first element. That definitely will run crazily. So this is an incorrect implementation. Instead of that, we have to make sure that after we call the insert blank, we will skip the next element of the while loop and check the next element. So assume that the preconditions for path list is satisfied. For which list will path list work correctly? Well, we know that the first choice is incorrect. For all linear linked lists, that's incorrect because we have already found some bugs of this implementation. For choice B, for no linear linked list, actually is also incorrect because if the original list is null, then there's no problem. If the original list has one element, then the while loop will check that the next element equals to null, so the incorrect code that has been executed inside of while loop will not work for the list that only has one node. So choice B, we also don't have to consider choice B. Choice C is our correct choice, only for lists that contain fewer than two nodes. Choice D and choice E actually, if we combine the results of choice D and also choice E, then that will be choice C. So choice C is the relatively complete answer. Okay, let's check the last question of this video. It's about our our concept of the traversal content in the traversal pre-order. So during the traversal, each element when accessed is pushed onto an initially empty stack as of stream. And what output is produced when the following code is executed? Okay, the following code only contains two very simple lines. But remember, during the traversal, there is a stack to store the output of this traversal in a pre-order method. But it's a stack, which means that the first element will be in the last element of the stack if you want to pop it out. So among these two lines, the first line is that we check while the S this stack is empty or not. So if the stack is not empty, it tries to do the following thing. It continues to pop out the content of this stack by calling system.out.print as.pop. So which means that if we have the original correct traversal of the pre-order of this given tree, after we executed these two lines, it will be reversed, right? Because originally it would have been stored inside of a stack. But the popping procedure, if we pop out each element of the stack gradually, actually it's a reverse order. So we only have to check that what's the pre-order of the traversal of this tree, then we reverse it. Remember that the rule of a pre-order. What's the pre-order of a traversal of a binary tree? Actually, it means it will execute the root element first. Then it will check the root element of its left subtree recursively. Then it will recursively check the root element of its right subtree. So that means, given this tree, first it will check A. Then since it has left subtree, so it will check K. Since K does not have left subtree, it will check the right subtree of K. So the third element has been inserted into the stack will be C. The fourth element that will be inserted will be the root of the right subtree of A. That will be P. Then after P has been inserted into the stack, since it has its left subtree, which happens to be a leaf, so R will be inserted next. Then F will be inserted next as the last one. Now, after we pop out, it will be the reverse order, which means the F will be pop out first. So that means we only have to check the choice C and E. And if you remember what we just described carefully, actually it will pop out as the following sequence: F, R, P, C, K, A. So the choice E will be our correct choice. Alright, thanks for listening to this video. If you are more interested in joining our class about how to get better grades in AP Computer Science in AB level, please don't hesitate to visit our website. Thanks. See you next time.